In this video, we will look about what a parabola is and we will derive its equation. Okay. So first of all, parabola is a part of conic section. The other parts are circle, ellipse, hyperbola, and parabola. In my other video, you can see how the conic, a section of conic that we call conic section, is related to parabola and ellipse, like these figures. Okay. So the curve parabola. Is the locus, or I can say that the collection of all the points in this plane. The parabola is a collection of all the points in this plane such that the distance from the fixed line and the distance from the fixed point is always equal. Okay, so let's say that we have a figure, all the points are like this. So if this is the parabola, then the distance, this distance should be equal to this distance. Okay, so if let's say this is point B, parabola point, it intersect on the parabola at point P, and the fixed point here is F. So PB should be equal to PF. Okay, so this is the condition, that PB equals to PF. PB is distance of fixed line from the parabola, and PF is distance of fixed point from the parabola. Okay, you can take any point on the parabola and it will definitely satisfy this equation. Okay, so this distance is equal to this distance. Let's say this point is B2 and this point is B2. Okay, or you can say this. Okay, so this point will be P3 and this point will be P3. Note that this distance should be perpendicular distance, and yeah, this should be perpendicular. Okay, and this distance is just the distance from this point to this point. Okay, we can calculate these by using distance formula. Okay, so I will again say that P2 equal to P2F, and for this this P3 point, P3F equal to P3B3, that is P3B3 equal to P3F. Okay, so this is the condition of parabola, that the distance from the fixed line is equal to the distance from the fixed point, the set of collection of all the points. So this is very important, and we will use this definition to derive our equation of parabola. Okay, so let's move forward. This fixed line is known as directrix. Okay, so this fixed line is known as directrix, and this fixed point is known as focus. Yeah, and we have focus, a directrix, and a vertex. Vertex is where the axis of parabola and the parabola intersects. Okay, so axis of parabola is perpendicular to the directrix. As you can see here, this line is perpendicular and passing through the focus. Okay, so perpendicular to the directrix and passing through the focus. So this will be the axis of parabola, and the point where parabola and the axis intersect is vertex of the parabola. So this point will be vertex of the parabola. Now move forward. So these are the four basic terms of parabola. Then we have to derive the equation of parabola. So we will be deriving the very basic and standard equation of parabola, which is y square equals to 4ax. Okay, so we will be looking at four other parts of parabola, but let's start with y square equals to 4ax first. All right, so let's say for this derivation, we have to assume some basic conditions that should be taken in the mind. So let's say this is the line directrix, and we have coordinate axis here. So this is the coordinate axis, this is y axis, and this is x axis. Okay, so if this point will be origin at now, and let's say this is the directrix, and we are taking the directrix at a distance. Okay, this is our assumption. So this point will be, because it is in negative of x axis, so this will be minus a, and comma 0, because the y coordinate is not anything here. Now let's say the focus is here, so this distance is also a, so focus will be again, because this is origin 0 comma 0, so I will say that this point will be a comma 0. Okay, so this is our focus. Now the parabola, for such condition, yeah, the most important thing here will be, this is directrix, and the distance between directrix and focus, this is our focus. So here you can see that the distance between directrix and focus is a plus a, that is 2a. So the first point to understand here, that directrix and focus are separated by distance 2a. So I can say that distance between directrix and focus is equal to 2a. These points are commonly asked in question of parabola. So focus, coordinate of focus are here a comma 0. Third point to be noted is equation of directrix. Equation of directrix, because this line is cutting at minus a, so I can say that x here, x equals to minus a, because you can note here that for every point on the line x coordinate is always minus a. Yeah, this is true, that for every point x coordinate is minus a, so I can say that the equation of this line is x equals to minus a. So I can also write it like this. So x, by taking it, x plus a equal to 0. So equation of directrix is x plus a equals to 0. So these are the 3 points discussed till here. Okay, so let's say our parabola goes like this. Okay, this so let me draw it again if I can. So if this is the parabola, then I can say that for every point P on the parabola, the distance from the directrix and the distance from the focus is equal. Okay, so let's say this point is B and this is focus F. So what we have to do is PB equals to BF. What we have to do is PB equal to BF. Okay, so now the important point is let the coordinate of P point be x comma y, because whenever you have to find out the equation of any curve where it is parabola, so always let the point be x comma y, because we are about to find the locus of this parabola. Okay, so let the point be x comma y always. Okay, and because this point is x comma y, we can say that this length here till P, this length is y. So the coordinate of this y coordinate of this B point will be y, and as you can see here on the whole line the x coordinate is always minus a. So coordinate of point B are minus a comma y, and the coordinate of f are already with us, that is a comma 0. Okay, so I can easily write PB by using our distance formula, which will be the under root of abscissa square and plus or difference of ordinates square. Okay, so abscissa, difference of abscissa will be x, and minus of minus a will be x plus a. So x plus a square under root of x plus a square plus, and difference of y coordinate will be y minus y 0, so it will be 0, nothing. Now comes to PF. PF will be x minus a, the square of x minus a, plus y minus 0, that is y square. Okay, you can see here y minus 0. So if I square both sides, I will get x plus a square equal to x minus a square plus y square, and from here I can get easily y square equals to x plus a square minus x minus a square. So this is a plus b square minus a minus b square, and as you open it, x square plus a square plus 2ax, x square plus a square plus 2ax, and minus of x square plus a square minus of 2ax. Everything will get down other than 2ax and 2x, so they will add up and give you 4x. So we got here that the equation of parabola is y square equals to 4ax. Yeah, this is the equation of parabola. So important point here to note down is that the directrix is 2a, length of directrix and focus is 2a, the focus is a comma 0, and the equation of directrix is x plus a for this parabola. Okay, now moving on, we can have other parabolas too. So as we have seen here that y square equals to 4ax is the equation of parabola, which goes something like this. Okay, if I other than that, if I take y square equals to minus 4ax, so it will go like this. Okay, now there are another parabola which is x square equals to 4ay. Whenever it is x square, so this goes like this. Okay, I can derive this equation also. What we have to do is in this case the equation of directrix is here, that is, you can see here that the coordinate is 0 comma minus a, the y coordinate is minus a every time, so I will write y equals to minus a. The equation of directrix will become y plus a equal to 0, and let's say, and the focus here will be 0 comma a, and you can see here the distance between focus and directrix is again 2a. Okay, so if you take any point here, P point, and the distance of this P point from the focus F and from the directrix let's say PB should be equal to PF, and as you will do it, you will get again that x square equals to 4ay. This is the equation. And if you have x square equals to minus 4ay, it will be downward opening parabola, okay, and symmetric to what? Y axis. Okay, so note down here that the parabola y square equals to 4x is symmetric to x axis, okay, and the parabola x square equal to 4y is symmetric to y axis. Again, the x coordinates here are always taken positive, because if you take any negative coordinates, then it will be equal to y square equal to some negative thing, and this is not possible. Okay, so we only put in the domain, because domain means input to y square equal to 4ax are only positive real numbers. Okay, this is important. Now for the sake of doing questions, let's say we have a parabola y square equals to 8a, then we have to find the focus and directrix. So because it is y square equal to 4a, it is of type y square equal to 4x, so we can draw roughly that this will be like somewhere like this. Okay, so this is, let's say, y square equals to 8a. Now we have to find out the coordinates of focus. We know that the coordinate of focus are a comma 0 in our standard standard equation, this equation. So by comparing this equation with the above given equation, we can easily get that 8a equal 8 y square equals to 8, this is x, y square equals to 4ax equals to 8x. So we will get 4a equal to 8, and a will be 8 by 4, which will be 2. Okay, so the focus will be 2 comma 0. So here we get focus 2 comma 0. Equation of directrix is x plus a equal to 0, and a is 2. So equation of directrix is x plus a equals 0, which will be x plus 2 equal to 0. Now the last point is the latus rectum. So latus rectum of parabola. Okay, so latus rectum of parabola is the parabola have, when a line parabola have a line which passes through the focus, if this is the focus, and perpendicular to the axis, and cuts the parabola at 2 points. Okay, such line which passes through the focus and the end points lie on the parabola. So this line segment is known as latus rectum, and the length of latus rectum can be easily calculated, as I will do here. We know that for every point, the equation of the length of the point from the directrix is equal to length of the point from the focus. So I will say that PB equal to PF, and PB is, because this distance we know that 2a, so this PF should be 2a, and this is also 2a because of symmetricity. So length of LR, latus rectum, will be 2a plus 2a, that is 4a. So in our this parabola, the length of latus rectum will be 4 into a, and a is 2 here, so 8. Okay, that's all. This is all about the parabola. Okay, thank you very much.